Expectation for joint distribution. In the previous discussions, we had learnt about mathematical expectation, variance, and standard deviation. Mathematical expectation is nothing but the arithmetic mean or the average. But all that discussion went only for the single random variable, which is usually denoted by X. And before this also, we have talked about the joint distribution. Whenever in place of one random variable, we are dealing with the two random variables simultaneously, say X and Y. So accordingly, the joint probability function or the joint density function is given by f of xy. So in that case, whenever two random variables X and Y are involved, I will be talking about the joint distribution. And now we will be extending our topic of mathematical expectation, variance, and standard deviation for the joint distribution. Now, whenever we are talking about the random variables X and Y, there are again two different possibilities. One of the possibility that is that X and Y are two discrete random variables. So accordingly, the rules or the definitions or the terminologies will be defined appropriately. Whenever I'm talking about the continuous random variable, the notations will change accordingly. So here we talk about the expectation for the joint distribution. So assuming that X and Y are two discrete random variable with a joint probability function f of xy, then mean or expectation of random variable X and Y are respectively defined and denoted by mean and expectation for the random variable X will be defined separately, Y will be defined separately. It is mu X which will give you expectation of X, summation over X, summation over Y, X multiplied by f of xy. See, in calculation of expectation of X, always we are multiplying X with the function that is probability function f of X. But here, as we are dealing with simultaneously two random variables X and Y, I will be calculating expectation of X, that is mu X, which is equal to summation over X, summation over Y, X multiplied by f of xy. Similarly, mu Y will be nothing but expectation of Y, which will be calculated by summation over X, summation over Y, Y multiplied by f of xy. So every random variable Y will be multiplied by the joint probability function, and summation will be taken over X as well as summation will be taken over Y. Similarly, whenever I have the random variables X and Y in the continuous form, so if X and Y are two continuous random variables with probability function f of xy, then mean or expectation of random variable X and Y are respectively given by. Always, you know, in case of discrete, it is given by summation. And in case of continuous random variable, that summation gets converted to integral. So mu X will be nothing but expectation of X, which will be calculated by integral minus infinity to infinity, integral minus infinity to infinity, X multiplied by f of xy dx dy. Similarly, expectation of Y, that is E of Y, will be given by integral minus infinity to infinity, integral minus infinity to infinity, Y multiplied by f of xy dx dy. Similarly, as what we did in the earlier case of discrete random variable, it was summation. Summation over X, summation over Y, X multiplied by f of xy. Here it is integral X multiplied by f of xy, and it is integrated with respect to X as well as with respect to Y. So expectation of Y will be integral minus infinity to infinity y f of xy dx dy. Once you have to integrate with respect to X, second time you have to integrate with respect to Y. So this was all regarding the expectation. Abhi, I know that definition of variance was expectation of X minus mu whole square. So I will be now defining the variance for the joint probability function. How you get the variance for the joint probability function? If X and Y are two discrete random variable with joint probability function f of xy, then variances of random variable X and Y are respectively denoted and defined as. See, the notation for getting the variance for random variable x will be var x or sigma x square, which is x minus mu whole square as per the definition. But here, as we are distinguishing between the expectation for x as well as expectation for y, here it will be expectation of x minus mu x whole square. And for discrete random variable, what it will be? Summation over x, summation over y, x minus mu x whole square multiplied by f of xy. This rule I know, whichever quantity is given for calculation of the expectation, that should be taken inside the summation and multiply by the corresponding probability function. Here in case of joint random variables, the probability function is f of xy. In case of discrete random variable, similarly, the variance which will be sigma y square for random variable y, it will be expectation of y minus mu y whole square. How you calculate expectation of y minus mu y whole square? It is summation over x, summation over y, y minus mu y whole square multiplied by f of xy. So whichever quantity is taken for a calculation of expectation, that will be multiplied by the joint probability function and taken over summation with x as well as summation over y. This is the possibility or the definition or the value to be calculated for the variance of y in case of discrete random variable. On the contrary, whenever we try to convert this particular thing in the continuous random variable form, this summation will be converted to integral, and that integral is taken from minus infinity to infinity. So var x is nothing but sigma x square, which is expectation of x minus mu x whole square. Why I am taking mu x? Because mu in general was the expectation, but here as we are talking about the different terminologies, expectation of x is denoted by mu x, expectation of y is denoted by mu y. If x and y are two continuous random variable with joint probability function f of xy, then variance of random variable x and y are respectively defined and denoted by sigma x square, which is expectation of x minus mu x whole square, given by integral minus infinity to infinity, integral minus infinity to infinity, x minus mu x whole square, f of xy dx dy. It will be a case of double integral when we are calculating it for the continuous random variable. Sigma y square, it will be expectation of y minus mu y whole square. But how to calculate expectation of this in case of continuous random variable? Integral minus infinity to infinity, integral minus infinity to infinity. One is the limit for x, another is the limit for y minus mu y whole square f of xy dx dy. So this is how the case is in case of calculation of variance for continuous random variable. So we have talked about the mathematical expectation for random variable x, mathematical expectation for random variable y, variance for random variable x, variance for random variable y in both the situations. One of the situation can be discrete random variable, other situation is continuous random variable. One additional term is associated here whenever we talk about the joint probability function, that is called as covariance. जैसे वहां पर स्टैंडर्ड डेविएशन होता था, वैसे ही यहाँ पर कोवेरियंस है. वेरियंस इज डिनोटेड बाय सिग्मा एक्स स्क्वायर, sigma y square, right? Covariance is the joint notation used for x as well as y. So let x and y be two discrete random variable with joint probability function f of xy, then covariance of x and y is denoted and defined by, it is sigma xy. Sigma xy is nothing but covariance of xy. This is the notation used for covariance. Sigma x square is individually variance for x. Sigma y square is individually variance for y. Covariance of x and y is sigma xy, which is covariance of xy. product of x as well as y. Expectation of x minus mu x into y minus mu y. It is product of x minus mu x and y minus mu y and uska expectation lena hai. So how is this expectation given by? I know that whenever we have to calculate the expectation, it will be summation over x, summation over y, x minus mu x into y minus mu y multiplied by the joint probability function. So this is the case whenever it will be a discrete random variable with a joint probability function f of xy. So one additional term is associated here which is called as covariance of xy given by sigma xy. In case of continuous random variable, so let x and y be two continuous random variable with a joint probability function f of xy, then or joint density function f of xy, then covariance of x and y is denoted by sigma xy, which is covariance of xy, expectation of x minus mu x into y minus mu y, the product of x minus mu x and y minus mu y. But continuous random variable में क्या होता है, summation of discrete random variable gets converted to integral. So integral from x is equal to minus infinity to infinity, y is equal to minus infinity to infinity, x minus mu x into y minus mu y, f of xy dx dy. I will have to calculate the integral with respect to x as well as with respect to y. So this was the covariance, which is additional term to be calculated for joint distribution or joint random variable x and y. So that is denoted by sigma xy, which is covariance of xy. Sigma x square is variance of x. Sigma y square is variance of y. Additional quantity apart from this can be asked is coefficient of correlation. What is coefficient of correlation? It is given by rho sigma xy upon sigma x into sigma y. Means covariance निकालना है xy का, then sigma x as well as sigma y, which is nothing but your square root of the variance, and that ratio is always lying between -1 and 1. तो आपको क्या क्या पूछा जाएगा? एक्सपेक्टेशन ऑफ एक्स, एक्सपेक्टेशन ऑफ वाई, वेरिएंस ऑफ एक्स, वेरिएंस ऑफ वाई, कोवेरिएंस ऑफ एक्स एंड वाई, कोएफिशिएंट ऑफ कोरिलेशन. Depending on the nature of random variable, whether it is discrete or continuous, I will be evaluating these many quantities. And lastly, our coefficient of correlation should lie between -1 to 1. What is sigma? Sigma is given to you as sorry, what is rho? Rho is given to you as sigma xy upon sigma x into sigma y. What is sigma xy? Sigma xy is nothing but the covariance of random variable x and y. Sigma x is nothing but positive square root of variance of x. Sigma y is positive square root of variance of y. And accordingly, this particular ratio, which is rho, called as coefficient of correlation, will always lie between -1 and 1. So for the joint probability function f of xy or the random variables x and y, corresponding terminologies will be calculated. There are certain theorems associated with this joint random variable x and y or the covariance x and y. What is the first theorem? Sigma xy, which is covariance of xy, is given by expectation of xy minus expectation of x into expectation of y, which is, this is denoted by mu x and this is denoted by mu y. So it can also be called as expectation of xy minus mu x into mu y. Now what is the definition of covariance of xy? Covariance of xy, that is sigma xy, is expectation of x minus mu x into y minus mu y. Open the bracket, x into y, x into mu y, right? Mu x into y and mu x into mu y. Expectation of all these particular terms will be individual expectation. So expectation of this xy, mu x into expectation of y, Mu x y it is taken outside because it will be a constant quantity, some finite quantity. Finite quantity हमेशा constant term बाहर लिया जाता है when you calculate the expectation for any random variable. So mu x itself is the expectation of x, which will be a finite quantity. Therefore, it is taken outside, and this is expectation of y minus mu y into expectation of x plus ये कांस्टेंट टर्म एज इट इज है तो एक्सपेक्टेशन ऑफ कांस्टेंट k is k itself, so it is mu x mu y itself. Now what is expectation of y given by mu y, what is expectation of x given by mu x? अगर आप देखोगे so these particular two quantities are getting एडेड, सो एक आपका कैंसल हो जाएगा, -2 + 1 इज -1, या अगर आप देखोगे तो ये दोनों में से एक कैंसल हो जाएगा, दिस इज कैंसल्ड विद दिस, ओनली आई एम लेफ्ट विद mu x mu y, या यू एड दिस टुगेदर सो इट इज -2 एंड दिस इज +1 which will be giving you answer as -1. So आपका covariance of xy is expectation of xy minus expectation of x into expectation of y. This is what we have tried to prove. So sigma xy, which is covariance of xy, is expectation of xy minus mu x into mu y. Mu x is expectation of x, mu y is expectation of y. If x and y are independent random variables, this expectation of x into expectation of y is expectation of xy. So this subtraction will be giving you 0. And that is what they are trying to show or tell us in the second statement or the theorem. So if x and y are independent random variable, then sigma xy is 0, because if x and y are independent, then expectation of xy will be expectation of x into expectation of y. This we know, this is the property of the random variable when they are independent. So in case of independent random variable, expectation of the product is product of individual expectation. Expectation of product xy is product of individual expectation. E of xy is written as E of x into E of y. So as per the theorem statement number 1, sigma xy will be expectation of xy minus expectation of x into expectation of y. But this is equal to this when they are independent. So for x and y as independent random variable, this minus this is going to give you answer as 0. And I say that covariance of xy is equal to 0. So x and y are independent, covariance of xy is 0. In all other cases, covariance of xy is expectation of xy minus mu x into mu y. The third statement what we have, var of x plus minus y is var x plus var y plus minus 2 times covariance of xy. So whether you are taking variance of x plus y or you are taking variance of x minus y, it will be var x plus var y plus minus. Accordingly, whenever it will be plus, it is plus. Whenever it is minus, it will be minus 2 times covariance of xy. So this is another statement what we can be asked to prove. So what do you understand by definition of variance of x? Variance जिस किसी का भी लेना है वो यानी क्या होता है, expectation of x minus mu x or mu y whole square. Here you have seen prior to this, whenever I am calculating the variance of x, variance is nothing but expectation of x minus mu x whole square or whatever is the quantity to be calculated. So similarly, I am calculating here variance of x plus minus y. So variance of x plus minus y means expectation of x plus minus y minus mu x. Abhi mu x and mu y both are involved here. So I will be writing down mu x plus minus mu y square. So expectation of this random variable minus their corresponding expectations whole square. Now apply the formula. Collect them together. X minus mu x put together plus minus y minus mu y together. and then you are taking square of both the sides, right? So here, if you see what I have done, x plus minus y minus mu x plus minus mu y में से x is connected with mu x, y is connected with mu y, बीच में plus minus है. Now expand this, a plus b whole square or a minus b whole square. What will be the middle term only changes, sign of middle term changes. A plus b whole square is a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square. So when I do this, a plus minus b whole square, it is a square plus b square plus minus 2 times a into b. Now you take expectation of all the terms. समझ में आ गया? पहले तो definition of variance. What is var of x plus minus y? It is expectation of x plus minus y minus expectation of x plus minus expectation of y whole square. I connected or related x with mu x. I tried to connect y with mu y. In between it will be plus minus. Now a plus minus b whole square. It is a square plus b square plus minus 2ab. Now take expectation of all the terms. So expectation of this, 2 times expectation of product. This is expectation, this is variance of x, this is variance of y. Expectation of product is nothing but covariance जो अपन ने definition में देखा था. So var of x plus minus y is var x plus var y plus minus 2 times covariance of xy, or symbolically if we have to write, it is sigma square of x plus y is equal to sigma x square plus sigma y square plus 2 plus minus 2 times sigma xy. So this was all regarding the statement of the theorems as well as the variance